All right, let's dive in. Today, we're taking a look at a concept that's, well, pretty wild. Panspermia.
Panspermia, yeah, it really makes you rethink where life comes from, the whole origin story.
So instead of that primordial soup idea, the classic one, this is saying that life, or at least the stuff that makes it up, actually came from space.
Yeah, that's basically it. And it might sound like science fiction, but some pretty serious scientists are looking into it. We're going to be digging into some of the work of Chandra Wickramasinghe and Fred Hoyle. They've been researching this for decades.
I'll admit, the thought of, life hitching a ride on a comet kind of feels like a movie plot. But hey, I'm open to being convinced. So where do we even begin with this theory? Why even consider panspermia in the first place?
Well, we have to start with the traditional idea, right? The primordial soup. The problem is there's a bit of a disconnect between that theory and what we're finding out about early Earth.
Okay, so what's the issue with the primordial soup idea?
It's all about timing. When we look at the oldest fossils, they're almost 4 billion years old, which is basically right when Earth was able to support life. That's not much time for life to pop out of a bunch of chemicals.
So it's like if you were baking a cake and it was fully done the second you turned on the oven.
Yeah.
Something just seems off.
Exactly. And that's where panspermia comes in. Maybe life didn't have to start from nothing here on Earth. What if it was already out there, just kind of waiting for the right place to get going?
That's a pretty big shift in how we think about things. But hold on, if we're talking about life actually traveling through space, how would that even work?
That's where we get to comets. Comets are way more than just frozen water. They're full of these organic molecules, and those are the building blocks of life. And there are so many comets, especially in a place called the Oort cloud.
Oort cloud.
It's basically a giant sphere of icy stuff that surrounds our solar system. Think of it like a giant cosmic freezer, but instead of leftovers, it's packed with trillions of comets.
Okay, so we've got comets with all this potential for life and tons of them. But how do they get from way out there in the Oort cloud to, here?
Sometimes, a passing star will kind of nudge these comets out of their orbits, like a cosmic billiards game. These icy messengers get sent hurtling towards the inner solar system, and that's where Earth is.
Like a cosmic delivery service, huh? But even if they brought these building blocks, wouldn't life still have to, put itself together here?
That's one possibility, but some people who support panspermia go even further. They think life itself, not just the ingredients, maybe started somewhere else and then came here.
You're saying actual living things hitched a ride on a comet. Is there any evidence for something that crazy?
There have been some interesting findings. One example is the Murchison meteorite. It landed in Australia back in 1969, and when they looked at it, it had these organic molecules. But the really cool thing is it also had stuff that looks like fossilized microorganism.
Wait, fossils from space, doesn't that kind of seal the deal?
It would be amazing, but there's a catch. They're not fossils of living cells. The heat and radiation from space travel basically qualified them. They changed. So it's tough to prove for sure that they were alive.
So it's like finding a super old, burnt piece of bread, right? You can tell it was bread, but it's not like you could eat it, to be sure.
Perfect analogy. It's a puzzle. They look like they might have been alive, but all that space travel makes it hard to say, for sure.
Okay, so meteorites are giving us some clues. Anything else that suggests life, or at least the stuff it's made of, might come from space.
There's something a little closer to home. Scientists found living microorganisms way up high in Earth's stratosphere. So high up, they couldn't have come from the surface.
Are we talking about bacteria hitching rides on airplanes or something?
No, nothing like that. These are probably coming from space, just raining down on us all the time. We just can't see them.
Hold on. So we've got comets bringing the building blocks, meteorites with maybe fossils, and now microorganisms falling from the sky. It's starting to feel like Earth is less like a closed system and more like a cosmic bus stop.
That's a key part of panspermia. It suggests that planets, maybe even whole star systems, are trading biological material way more often than we thought.
Mind-blowing, for sure. But if this is all true, wouldn't it also mean life could exist on other planets? If it can survive a trip through space and land here?
That makes sense, right? And that's what a lot of people who believe in panspermia say. When you think about how big and old the universe is, the chances of life being out there somewhere seem pretty good.
It's a pretty exciting and maybe a little scary thing to think about, but wouldn't alien life forms have to deal with some serious challenges to survive on a new planet?
Oh, absolutely. And that brings us to another big idea in panspermia: viruses.
Viruses, aren't those the bad guys? Do they just cause disease?
That's what most people think. But some scientists are starting to think that viruses might actually be really important for evolution. They're like genetic hackers, inserting their own code into cells. And sometimes that leads to good mutations.
So instead of just causing trouble, they could be bringing in new genetic information that helps life change and evolve. That's a whole new way to think about them.
Exactly. And get this. A good chunk of the human genome, our DNA, is made up of viral sequences. It's like these invaders became a part of us.
Whoa, that's kind of creepy, but also really cool. Okay, so we've got comets potentially starting life, meteorites with maybe fossils, microorganisms falling on us, and viruses helping things evolve. That's a lot to take in. Where do we go from here with this whole cosmic investigation?
Well, let's shift gears a little and talk about the ecosphere.
Ecosphere, you mean like those glass balls with the little ecosystems inside?
Not exactly. In this case, it's about the habitable zone around a star. You know, that sweet spot where it's just right for liquid water to exist. And we know water is super important for life.
So like Goldilocks, but for planets. Not too hot, not too cold, just right for life.
You got it. And astronomers are finding more and more planets in those zones. So the chances of life being out there, whether it started there or came from somewhere else, are getting better all the time.
That's incredible. But even if life did arrive from space, it would still have to evolve into all the different forms we see, right? That would take, like, forever.
That's one of the big questions Panspermia brings up. How do we explain how fast complex life appeared? It's tough even for regular evolutionary theory.
So how does Panspermia explain it? Is there an alternative to the slow, step-by-step evolution we usually hear about?
Actually, yeah. Hoyle and Wickermassing, the scientists we talked about, came up with this idea called evolution by jumps. They said maybe instead of gradual changes, life gets big chunks of genetic information all at once, and that causes a lot of diversification.
So instead of slowly climbing a ladder, it's more like evolution is taking these giant leaps forward. What could cause that kind of jump?
Remember those comets? They might be carrying a whole library of genetic information, just waiting to be absorbed by life forms that already exist.
Wait, you're saying comets could be like cosmic software updates, bringing in new genetic code to make evolution happen faster? That's wild.
It is wild, right? It makes us think about the history of life in a whole new way.
This is so exciting.
Yeah.
But before we get too carried away with comets raining down genetic upgrades, maybe we should step back a bit. What are the big implications of all this? If life really is all over the universe, where does that leave us?
That's the big question, isn't it? Are we just one small part of a giant interconnected tree of life?
It makes you wonder if there are other intelligent beings out there looking at the stars and asking the same questions we are.
And if there are, do they know about us? Have they been here before? It's something people have wondered about and written stories about for a long time. And if they are they aware of us? Have they been here before? These are questions that have, really fascinated scientists and philosophers forever.
And we were also talking about that evolution by jumps idea, where evolution isn't always this slow, gradual thing.
Right. Hoyle and Wickermassing, they said that sometimes life could get a whole bunch of genetic information all at once. And that's what leads to these, big changes in diversification.
But what could cause those sudden jumps? They talked about comets playing a part, right? Those cosmic couriers we were discussing.
Imagine comets being like delivery systems for new genetic stuff. They're carrying this huge library of information that could get mixed in with life that's already here.
So it's not just random mutations slowly changing things.
Right.
It's like life gets this sudden upgrade from space, leading to all sorts of new adaptations.
Exactly. It's a pretty different way of looking at evolution, but it might explain some of the weird parts of life's history that don't quite fit the traditional model.
Like what? Give me an example.
Well, think about the Cambrian explosion, right? That was about 540 million years ago. There was this sudden burst of new life forms, all these different body plans and adaptations. It's like it came out of nowhere.
Like evolution suddenly hit the gas pedal.
Yeah. And some scientists think that maybe, just maybe, it was caused by an influx of viral genetic material from space.
Hold on, you're saying those cosmic viruses we were talking about could be behind one of the most important events in the history of life on Earth?
It's a cool idea, right? Remember, viruses are basically packets of genetic information, and they can survive in a dormant state for a really, really long time.
So they're like little time capsules, carrying the blueprints for new life forms across the vastness of space.
You could say that. And if they can survive a trip through space, it's not a stretch to think they could integrate their genetic material into life here when they arrive.
That opens up a whole new world of possibilities for how life has evolved here, and maybe on other planets too.
Definitely. It really makes us rethink the forces that shape how life changes over time.
Okay, so we've got comets bringing the building blocks of life, viruses maybe causing these big evolutionary jumps, and this mind-blowing idea of a universe full of potential life. So where do we, as humans, fit into all of this?
That's the big question, isn't it? If life is all over the place, are we just one tiny branch on this massive tree of life?
It really makes you wonder if there are other intelligent beings out there looking up at the stars and wondering the same things we are.
And if so, are they aware of us? Have they visited Earth before? These are questions that have, really fascinated scientists and philosophers forever.
We also touched on the idea of evolution by jumps, this concept that evolution isn't always this slow, gradual thing.
Right. Hoyle and Wickermessing, they said that sometimes life could get a whole bunch of genetic information all at once. And that's what leads to these big changes in diversification.
But what could cause those sudden jumps? They talked about comets playing a part, right? Those cosmic couriers we were discussing.
Imagine comets being delivery systems for new genetic stuff. They're carrying this huge library of information that could get mixed in with life that's already here.
So it's not just random mutations slowly changing things. It's like life gets this sudden upgrade from space, leading to all sorts of new adaptations. But is there any scientific basis for these ideas? Or are we just venturing into the realm of pure speculation?
Well, there's this famous thought experiment, you've probably heard of it. It's called the Fermi paradox, and it basically tries to answer that question.
The Fermi paradox. Yeah, I've heard of that. It asks, if the universe is so huge and so old, and the chances of life are so high, why haven't we met any other civilizations yet?
Exactly. It's a paradox because, logically, we should have found some evidence of alien life by now. I mean, think of how big the universe is and how much time there's been for life to evolve.
So where is everybody? Are we really all alone in this vast cosmic expanse?
Well, there are a lot of possible explanations for that, for the Fermi paradox, I mean. Maybe we're just looking in the wrong places, or listening on the wrong frequencies.
Like trying to find a radio station, but you're on the wrong band.
Exactly. We might be missing signals from other civilizations because we don't have the technology to detect them, or maybe we just don't understand how to look for them.
Or maybe, just maybe, we're not as advanced as we think we are.
That's definitely another possibility. The universe is billions of years old, and we've only been technologically advanced for a tiny, tiny fraction of that time.
So compared to some other civilizations out there, we might still be in our technological infancy.
Exactly. There could be civilizations out there that are millions, even billions of years ahead of us, with technologies and understandings of the universe that we can't even imagine.
That's both humbling and a little terrifying. But if there are these super advanced civilizations out there, why haven't they reached out to us? Are they ignoring us? Studying us from afar? Or are they just too busy with their own cosmic affairs to bother with us?
Now we're getting into pure speculation. But it's fun to think about, right? Some scientists have proposed something called the zoo hypothesis, where these advanced civilizations know about us but choose to leave us alone. Kind of like observing a wildlife preserve.
So we're like cosmic zoo animals. That's a bit unsettling, but I guess it would make sense if they didn't want to interfere with our development.
Right. Or maybe they're waiting for us to reach a certain level of technological or societal maturity before they make contact.
Like they're giving us time to figure things out on our own.
Exactly. And maybe when we reach that point, when we're ready, they'll reveal themselves.
That's a hopeful thought. But until then, we're left with this tantalizing mystery of the Fermi paradox and the endless possibilities of a universe potentially teeming with life.
It's a mystery that continues to inspire scientific inquiry and ignite our imaginations.
Speaking of igniting our imaginations, I'm curious to hear more about how panspermia has influenced our understanding of the origins of life here on Earth.
That's a great point because it brings us back to the work of Hoyle and Wickermessing, right?
They weren't just proponents of panspermia, were they?
No, they actually challenged some of the conventional ideas about the nature of life itself.
What do you mean?
Well, they argued that the classic Darwinian model of evolution, while useful, has its limitations.
Limitations? How so?
It has trouble explaining the incredible complexity of life, all those intricate biochemical processes, and those seemingly impossible leaps in evolution.
So they weren't convinced that random mutations and natural selection could account for all of life's diversity and complexity.
Right, and that's why they propose this idea of an information-rich universe.
An information-rich universe. What does that even mean?
It means that maybe, just maybe, the blueprint for life is actually embedded in the very fabric of reality.
Okay, so instead of life being this random accident in a chaotic universe, you're saying it's more like the universe is inherently built for life, like there's some kind of cosmic code that's guiding the emergence of complexity.
That's the basic idea. Think of it as like a cosmic operating system, a set of fundamental laws and principles that favor the emergence of life.
So life isn't just a fluke, it's a built-in feature of the universe. That's a pretty radical shift in perspective.
It is, and it changes how we think about the origins of life, not just here, but everywhere in the cosmos.
This is all incredibly thought-provoking. But how does this idea of an information-rich universe fit with, the scientific method?
That's a great question. It's important to remember that this is still a theoretical framework, a way of looking at the evidence we have.
So it's not replacing traditional science, it's more like adding to our understanding of what's possible.
Exactly. It's about pushing the boundaries of our thinking and asking new questions about the nature of reality.
It's definitely pushing my boundaries. But I'm all for expanding our horizons. Is there any evidence to support this idea of an information-rich universe?
Well, think about the anthropic principle, It's the idea that the universe is fine-tuned for us, for observers like us.
So like the universe knew we were coming. That's kind of trippy.
It is, right. Think about it. All the fundamental constants of physics, the strengths of the forces, they're all perfectly balanced to allow for stars, galaxies, planets, and eventually life.
If any of those values were even slightly different, we wouldn't be here having this conversation.
Exactly. It's almost like someone or something set the dials just right for life to flourish.
But doesn't that suggest a creator, some guiding hand?
That's what's so interesting about panspermia and this idea of an information-rich universe. It blurs the lines between science and philosophy, between the material and the metaphysical.
So we're not talking about like a bearded guy in the sky, but more like an underlying intelligence built into the very fabric of reality.
Exactly. And this intelligence, if we can even call it that, might operate on timescales and in ways that we can't even begin to understand.
Wow, this is really pushing the boundaries of what we consider science. But that's what makes it so exciting. It's like we're peering into a whole new dimension of understanding.
It's a journey that requires us to be open to new ideas and to question what we think we know about the nature of reality.
And who knows what amazing discoveries await us as we explore these uncharted territories. But before we get lost in the vastness of the cosmos, let's bring it back down to Earth for a moment.
Sounds like a plan.
We've been talking a lot about the big picture of panspermia, the cosmic origins of life, the possibility of advanced civilizations, and the potential for an information-rich universe.
It's been a mind-blowing journey so far.
But what about the practical side of things? How can we use this knowledge to help us here on Earth?
Well, for one thing, it opens up new avenues for understanding life itself. If life came from space, then the ingredients for life are probably all over the universe.
That's huge for astrobiology, for looking for life on other planets, and even for understanding how life began right here on our own planet.
Exactly. Instead of just studying life as we know it, we have to start thinking about life as it could be in all sorts of different forms.
So panspermia isn't just about looking back to the origins of life, it's about looking forward to the possibilities of life beyond Earth.
Absolutely. It broadens our horizons, makes us think outside the box, and encourages us to look beyond our planet for answers to some of the biggest questions we have about our existence.
That's incredibly exciting. It's like opening a whole new chapter in the story of life. But what about more immediate practical applications? Can panspermia help us address problems here on Earth, like diseases or resource scarcity?
It's certainly possible. Remember how we talked about viruses being potential drivers of evolution? Well, if we can learn to harness the power of viruses, we might be able to develop new technologies, new medicines, and even new sources of energy.
So instead of seeing viruses as the enemy, we could potentially see them as allies, as tools for innovation and progress.
Exactly. And who knows what other secrets the universe holds, just waiting to be unlocked. Maybe there are cosmic solutions to problems we haven't even encountered yet.
This is all so incredibly inspiring. It's like panspermia isn't just a theory about how life began, it's a call to action. It's a challenge to embrace our cosmic heritage and work towards a future where humanity becomes a true citizen of the universe.
Well said. It's a future full of challenges, for sure, but also full of amazing possibilities. And as we continue to explore the mysteries of panspermia, we may find that the answers we're looking for lie not just within ourselves, but within the vast and wonderful expanse of the cosmos.
Those are some truly inspiring words to end on. But before we wrap up this deep dive, I'm curious to hear your thoughts on the ethical implications of panspermia.
Ah, yes, that's an important aspect that we haven't discussed yet. Panspermia brings up a lot of ethical questions, especially if we actually find evidence of extraterrestrial life.
Like what kinds of questions?
For example, how should we approach contact with an alien civilization? What responsibilities do we have to other life forms out there in the universe?
And what if we discover that life on Earth actually originated on another planet? Would that change how we see ourselves and our place in the cosmos?
These are tough questions, no easy answers. But they are questions that we need to start thinking about now as we explore the possibility of life beyond Earth.
It seems like panspermia isn't just a scientific theory, it's also a philosophical and ethical challenge.
Absolutely. It pushes us to broaden our thinking about the nature of life, the universe, and our own place within it all.
So, we've talked about a lot with panspermia, like comets bringing those building blocks of life and that crazy idea of the universe being like information rich.
Yeah, we've really gone deep on how a universe potentially full of life changes how we see ourselves, humanity's place and everything.
Totally mind-blowing stuff. But before we wrap up, I want to go back to something we kind of touched on earlier, the ethical side of panspermia.
Yeah, oh yeah, that's super important, especially if we actually find proof that there's alien life out there.
You said that panspermia makes us ask questions about, how we should handle contact with alien civilizations. What do you mean by that?
Okay, imagine we get a clear signal from an alien intelligence. Like, no doubt about it. How do we react? Do we answer? Do we try to keep it quiet?
Those are huge questions. And who even decides? Governments? Scientists? Everyone on Earth?
It brings up a bunch of complicated issues, like who's in charge? What are our responsibilities? Are there risks? Could there be benefits? Some people say we should be super careful, like what if we misunderstand each other or they try to take advantage of us or things even get violent?
It's like that saying, be careful what you wish for, right? We want to meet aliens, but what if it's not what we expect?
Exactly. But then there are those who say we got to take the chance, that it's a huge opportunity to learn and grow and understand the universe better.
It's that classic dilemma, curiosity versus being careful.
Yeah.
But the ethical stuff goes further than just contact, right? What about our responsibilities to other life forms out there?
Right. If life is all over the place, which is what panspermia says, we got to think about how we affect things on a big scale. Do we have to protect other life forms? Should we worry about contaminating other planets with our stuff?
It's like taking environmentalism and making it cosmic. We're used to protecting our planet, but what about protecting the potential for life everywhere?
That's a big shift in how we see things. And it's not just about what we do in space. What if we find out that life on Earth actually came from another planet?
Whoa, that would be wild. It would change how we see our whole history, our place in everything. Would we feel connected to that other world? Would we have to protect it? Would we even want to, go back to where we came from?
Those questions really make you think about who we are, our identity, our past, our future, and it shows how science, philosophy, and ethics all come together with panspermia.
It makes you realize that when we explore the universe, we're not just looking for answers. We're also trying to figure out what it means to be human.
And those questions, I think, are just as important as any scientific discovery we make.
Totally agree. This deep dive into panspermia has been amazing. We've looked at the science, the philosophy, the ethical challenges. It's something that really gets you thinking, changes how you see the universe, and honestly leaves you with more questions than answers.
That's the beauty of science, though, right? It's this never-ending search for knowledge, a journey of exploring and discovering. We're always pushing the limits of what we know and what we think is possible.
And who knows what incredible things we'll find as we keep digging into the mysteries of the universe. Maybe someday we'll have proof that life on Earth really did come from the stars. But until then, we'll keep exploring, keep asking questions, and keep sharing it all with you right here on The Deep Dive.
And don't forget to like and subscribe so you don't miss out on our latest deep dives into all the coolest, most mind-blowing topics in science and beyond.
And if you have any thoughts or questions about panspermia, let us know in the comments. We love hearing from you. Until next time, keep exploring.